So then, D part 1. State the meaning of half-life of a radioactive substance. This is the average time for half the particles to decay. Now this is the one that we would have learnt in our notes, the average time for half the particles to decay. Another possible definition or meaning of half-life could be the time for the activity of the substance to fall to half its original value. Pick one of those definitions and learn it. Don't try and work it out each time, so learn one of them. Either the average time for half the particles to decay, which is the one in our notes, or the time for the activity to fall to half its original value. Now this one applies the theory of radioactivity into a medical application again. The volume of blood in a person's body can be measured using radioactivity. A small quantity of a radioactive substance is injected into the body. After an hour, a small sample of blood is taken and its radioactivity is measured. The volume of blood can then be calculated. Part 2. 3 radioactive substances are available. One has a half-life of 5 seconds, one has a half-life of 30 minutes, and the third has a half-life of 1 year. Which one is best suited to this technique and why? So we're looking for which one is best suited to the technique and why. We're injecting something into the human body, so we want to minimise its half-life. We want to minimise the length of time that it has significant radiation, so half-life of a year isn't suitable. So we're coming down to 30 minutes or 5 seconds. Well, if it had a half-life of 5 seconds, that wouldn't give you enough time for it to mix with the blood and then take the sample. So the one that's most suitable is the half-life of 30 minutes. And it's long enough to mix with the blood. But short enough to avoid tissue damage or cell damage. So that's answering which one's best suited and why. So 1 mark for identifying it and 1 mark for why. It then also says explain why the other 2 are not suitable. So you must make reference to them in your answer or you won't get the 4 marks. 5 seconds. The half-life of 5 seconds is too short to mix with the blood. And the one with a half-life for a year, well, this is too long. It could cause damage to the body or to tissue or to cells, whichever word you prefer there. So 30 minutes, it's long enough to mix with the blood but short enough to avoid tissue damage. 5 seconds is too short to mix with the blood, so you wouldn't actually get any values. And 1 year, this is too long. It could cause damage to the body, tissue and cells. Now notice that question has a mark for the quality of written communication. In all likelihood, if my answer there was marked, if I had written that exactly in the exam and it was marked, I wouldn't get my mark for written communication because I haven't used full sentences, suitable punctuation and so on. That concludes the video cast on the past papers for radioactivity. It's one of those topics where you do have to learn your definitions and learn how to work out some of the calculations, including half-life. It's also one of the more ideal topics for testing how well you can read graphs. So if you're worried about reading and constructing lines and graphs, perhaps that's something you should practice. Can I just take this opportunity now to wish you luck with your exams?